Hello friends, so after completing the problem number 6, we are going to start with the problem number 7 where we have one function given and there is one equation which we have to solve, and we have to get the value of a and b with the help of second order partial derivative. So let's see guys how to solve such type of numericals. So here the value of z is given as u of x comma y into e to the power ax plus by. So this is a given function, what I was just now telling you, and here it is said that u of x and y is given such that the del square u by del x del y is equal to 0. It means the second order derivative of u is equal to 0 if I partial differentiate it with respect to x and y. Next, we have to find out the value of a and b such that this equation is equal to 0. So now guys, how to proceed? So it's simple, like if I want to find out a and b with this condition, so what I'll do is I'll find out these values and I'll put those values in the equation, equate it with 0, and then we can get the value of a and b. So for that we need to find out the different terms. So one is del x by del y, del x by del z by del y, then del z by del x, then del square z by del x del y. So these are the terms which we have to find it out. Now guys, let's start with that. So first of all, I'll find out del z by del y, and for that I need to partial differentiate z with respect to y. So now del z by del y. So here guys, in both the functions we have y, so we'll be applying the product rule of derivative. So according to it, it will be u of x comma y as it is, then derivative of this part is e to the power ax plus by into b plus e to the power ax plus by as it is, and the derivative of u is u dash, or I would say del u by del y. So guys, here since the value of u, or I would say the function u, is not defined, we will keep this as it is. So del u by del y as it is. Now this is the value of del z by del y. So now let's find out the value of del square z by del x del y, and for this we need to differentiate this partially again with respect to x. So we'll get, now guys, for that we need to differentiate his right hand side with respect to x as well. So on the right hand side there are two functions. So first function is a function of x and second function is also a function of x. So we need to again use the product rule of derivative. So b is as it is, and here if I apply the product rule we will get u of x comma y as it is, and derivative of this with respect to x partially is next plus, now I'll keep this term as it is, which is e to the power ax plus by, and the derivative of this term, that is the function u with respect to x, is del u by del x. So this is the value. Now let's differentiate the second term. So the second term is e to the power ax plus by del u by del y, and to this term will partial differentiate with respect to x. So guys, again here in this first function we have x, and if you observe the second function, it is del u by del y. So guys, u is a function of x and y, and when you differentiate with respect to y, it means you consider y as a variable of differentiation. So there might be some terms of x, so we can't say that del u by del y is a constant. So that is why we will treat this del u by del y as a function of x. So here both functions have x, hence I have to apply u into v rule, or you can say the product rule of derivative. So I'll write down that on the next page. So middle sign is plus, we will get e to the power ax plus by into del square u by del x del y plus, now I'll keep this term as it is and I'll differentiate this first function. So del u by del y into e to the power ax plus by into a. So guys, this is the value of del square z by del x del y. Now before proceeding, let's again read the question. So in the question it is given that the value of del square u by del x del y is equal to 0, and guys, we got this term here. So it means this value is 0. So what we'll do is we'll put this as 0, and from the whole this function we can take e to the power ax plus by common. So first of all, this b will go inside, so this will become ab, and guys, this u of x comma y, for simplicity I'll call it as u. So e to the power x plus by outside, so from here we will get a, b and u. So we'll write here. Now from the second function, as e to the power x plus by going outside, and we are multiplying this second term with b, so that will become b del u by del x, which will remain. So plus b del u by del x. Now from the third term, you can observe that this value is 0. So if this value is 0, this whole term will be 0, so nothing will left, and here e to the power x plus by outside, so from here we will get plus a del u by del y. So guys, this is the value of del square z by del x del y. So we got the first value as well as we got the third value. Now let's find out del z by del x, and for that I'll again partial differentiate this function with respect to x. So therefore del z by del x equal to u of x comma y as it is, derivative plus the second function as it, and derivative of this term is. So guys, here we got the value of del z by del x. Now what we'll do is we'll put all these values in this equation because we have to find out a and b. So let's put all these values in this equation. So here I'll write down the equation. Now let's put the values. So value of this first function is this. I'll put that value over here. Value of del z by del x is this. So we'll put this value here, and del z by del y is this. Now guys, if you observe, then in all the terms, the e to the power ax plus by term is there. So I can take this e to the power ax plus by outside from all the terms, and we'll put the value over here. So therefore, e to the power ax plus by outside. Now let's see what we get in the bracket. So this is the first function, and that is the value. This value I've taken outside, so this will remain in the bracket. So I'll copy it down. Now minus del z by del x. So this is the value of del z by del x. In this e to the power x plus by, we have taken it outside. So a into u will remain plus del u by del x. But guys, before this function we have negative sign, and that is why all these terms will become negative. So we'll get. Now next term is del z by del y, and we have negative sign. So let's see what is the value of del z by del y. So guys, this is the value of del z by del y. From this we have taken e to the power ax plus by outside. So we'll get b into u and del u by del y with negative sign. And now the last term is z. So let's see what is the value of z. So guys, z is the given function only. So this is the value of z. From this also e to the power ax plus by outside, so only u will remain. So here I'll say plus u is equal to 0. Now let's take the similar differential terms together. So we have here del u by del x terms. I'll take it together. Then del u by del y terms together, and remaining terms as it is. And I can shift this e to the power x plus by on the other side. It will divide here and we'll get 0. So here we'll get b from this del u by del x, and from here minus 1. So b minus 1 into del u by del x. Similarly, from del u by del y we'll get a and minus 1. And now if you'll see the remaining terms, all the remaining terms are the terms of u. So we'll take u common, and in the bracket we'll write from here ab, from here negative a, negative b plus 1 into u equal to 0. Now guys, let's keep these two terms as it is, and here again we can simplify it by taking a common. So now guys, if I take a common, then we will get b minus 1 as the first bracket and a common, and here also I can take negative 1 common, so it means in the second bracket I'll get a minus 1. So a I got from these first two terms, and this minus 1 I got from these two terms, and in both the terms we will get b minus 1 bracket. So I've written this directly, u equal to 0. Now guys, this is what the simplification is. Now from this we have to find out the value of a and b. So let's start. So guys, here if the answer is 0, it means the first term must be 0, second term must be 0, and third term must be 0, because we have the plus sign in between. So if all three terms are 0, it means we can get the 0. So now if I want to make first term, second term and third term 0, then let's observe the function. So let's talk about u. So can u be 0? Or can del u by del x be 0, del u by del y be 0? So answer is no. Because if u is 0, then del u by del x and del u by del y will become 0. So let's come back to the question. So here the question was given. So as I'm saying, let's say if u is 0. So if u is 0, guys, then this function would have been 0. It means value of z is 0. So there is no relation of getting any answer. It means u can't be 0. So if u can't be 0, then del u by del x can't be 0 and del u by del y can't be 0. So if these three terms are not 0, it means its coefficient has to be 0, because here we have multiplication, one term is not 0, so other term has to be 0, then only we will get 0 here. So therefore I'll say b minus 1 is 0 and a minus 1 is also 0. So you can compare here, or you can compare here also. If u is not 0, it means b minus 1 and a minus 1 has to be 0, and therefore guys we will get a equals to 1 and b equals to 1. So therefore the value of a and b, both are equal to 1. So I'm sure that you understood how I derived the answer. So guys, keep watching the videos and don't forget to promote this video to your friends, so that they can also get the best explanation of such type of problems, and they can also get the good marks as you'll be getting. Thank you very much.